So let's go over some of the basics of the Python, right? So the Python here. So I'm going to start with this NumPy here. And NumPy, as I mentioned, is one of the more or less the core component of the Python. Especially for us, we deal with mostly numerical calculations. So NumPy is very important to us. So what I'm going to do here is this. What you do is you're going to import this library. It's called modules within the Python. Import NumPy as NP. NP is any abbreviations of NumPy. So most of the time, people by convention use NP here, but you can choose yours own ways. Right? But it's not necessary. I will just stick with NP here. So import them. So now you can use this NumPy arrays here. So that's the first lines of command. Very straightforward. So I load these modules here. So now you can run the command here. You can click on this arrow buttons here, or run just these lines of command here. You can also do runtime here, run all the lines within this notebook here. So that's this command here. By the way, I just want to comment here. So this is a very interactive session. If you have any questions, you can either type in the chat room, you can speak up also as well. So now what I do next here is to introduce a variable x here and define a variable that is an array here. It's an array here. It defined to be array. First row is 1, 2, 3. Second row is 4, 5, 6. And then we're going to use this square bracket to represent those arrays of the data sets here. So that's just some of the syntax and to be familiar with. And then once I define this variable x here, there are a few things you can check here. You can take a look at these values here. You can see now is an array type. Array, you can imagine, is this particular array is two-dimensional array, and the two-dimensional array is very analogous to the matrix in the linear algebra. You can think about that. And then you look at the dimensions of this array, and then using this command called shape. And say this array here is 2 by 3 array, 2 by 3 array. And because it has 2 rows and 3 columns. And this essentially is 2 by 3 matrix. But array can be much more general than this 2-dimensional arrays here. It can be 3-dimensional. And can be 1-dimensional. So then in that case, it becomes a vector. In 3-dimensional array, sometimes people call it tensors. And it can be any arbitrary dimension. So it's more general than the concept of matrix. Matrix only refers to these 2-dimensional array. And you can always use shape to identify the so-called dimensions of this data here. And then right now it's 2 by 3. So we can have 2 rows, 3 columns here. But you can in 3 dimensions, that will include 3 numbers. So that is the x here. And now once you have x here, you can do the calculation. You can 2 times x here will give you this another arrays of that. And then you can do, let's say, define another arrays here to be array of 1 minus 1 here. Here. So now what I just defined here, y here is now by the way, let me make a screen bigger. Maybe I understand you maybe not be able to see it. Okay. So now y is a 1-dimensional vector. So you can see that y is here. So now let's look at it here. So now let's say I'm going to make a 3-dimensional vector. Here, let's say it becomes 0 here. So y becomes 3 here. So now what let's remind you again. So if you look at the shape, the y is 3-dimensional vectors here. So that it doesn't have the second numbers here. So if you look at the x here, shape here is a 2 by 3. All right. So then what I wanted to try this. Suppose now you can view them y as a vector, x as a matrix. And what I can do next is I can do matrix vector multiplications. Right? So like in the sense of the linear algebra. So the way you do that, to carry out the linear algebra operation, you can do x dot y here, x dot y. So now because 2 by 3 times a 3-dimensional vector give you a 2-dimensional vector. And that is x dot y. So this one will carry out matrix vector multiplication. Matrix vector. Very important here. And intuitively, you might say, I want to do x times y. You might do that, but you can see the result is different. If you do x times y here, that will give you a matrix. So it's sometimes very confusing here. The reason, because if you do this operation here, was doing element component-wise multiplications. And in this case here, you have to find how it does do component-wise multiplication, because on one hand you have a matrix, on the other hand is the vectors here. It's not so clear, and it has some convention to do that. So, but however, it's confusing, right? So this is component-wise. If you want to generate a linear algebra result, such as this product here is defined in terms of matrix multiplication, and then you have to use something called a dot here. And that's something just to keep in mind. A lot of times people make mistakes without aware of this. All right, so this is a very simple introduction of this NumPy array, NumPy here. So the next module I mentioned is this matplotlib here. And this is for plotting purpose, here. And this is very useful because most of the time when I have some data sets here, I want to visualize the data and see the results. And then one way of doing that is to use matplot library. And then to do that, you have to import these modules. And then you do import matplotlib as the PLT here. So that, and once you have that, and then you can show some plots here. For instance, what I'm going to do here is this. I'm going to generate 2 vectors here. One is a sequence of number, uniformly distributed from -10 to 10, and I use 100 numbers, uniform distributed between -10 and 10. So this is the x here. And then I'm going to say, plot generate another variable, y. Y now is, again, is an array. The NumPy here, I use the function exponential function. This is the exponentials of x here. And next, I want to plot the relationship between x and y. And I'm going to call this plot function PLT. This is from this matplot library here. This is modules here. And using this plot function implemented within this modules here. And you can see some of the syntax, how to use that. But the simplest way to use it is to say, this is the x-axis, this is the y-axis here, and even without mark, let's do some simple here. Just do this one here, and you can see you plot x relationship x versus y. Y-axis is x here. So as simple as that, so it's very simple. Of course, you can put in a little more things here, change the color, put in markers, and so on to more functions. But in the basic function that is very simple. It's plot x as function for y. So this is so-called plot libraries here.